Hey, Math 206, now that we have developed formulas for surface areas of prisms and cylinders and pyramids, let's move to more circular objects. So you've got a cone here, and what we want to do is to find a formula for the surface area of a cone by imagining it as being approximated by pyramids, where the base of your pyramid has more and more sides so that the base of the pyramid starts looking like a circle. So let's first remember what was the formula for the uh, for the surface area of a pyramid. So surface area for a pyramid was going to be the area of the base plus a whole bunch of triangular areas, and we found that to be 1/2 times the base times the height, which was that slant height for each one of those triangular lateral surfaces. So then when you add them all up, what you get is 1/2 the perimeter times that lateral slant height. So then when the number of sides grows and grows, the perimeter becomes really close to the circumference, C, which is 2 pi r. So to find the lateral surface area of a cone, it'll be the base area, which the base is a circle, plus 1/2 times the circumference times that length. And the base area, so the area of a circle, is pi r squared plus 1/2. The circumference is 2 pi r times L. So we can sort of simplify this and make it pi r squared plus 1/2 times 2 is just 1, so pi r L. So here's a formula for the surface area of a cone. Let's see how this works in this example. You've got a right circular cone with radius 3 centimeters, height 4 centimeters, which means that its slant height here is 5 centimeters. So the surface area will be the base area, pi r squared, r is 3, so pi times 3 squared, plus pi times r times L. So pi times the radius, which is 3, times the slant height, which is 5. And all of this will be in terms of centimeters squared. So we get 9 pi plus 15 pi centimeters squared, or 24 pi square centimeters. And of course, when we're dealing with these applications, it might not be useful to have that symbol pi in there. So then we replace it with an approximation, 3.14. So we'll say it's approximately 24 times 3.14, which is 75.36 square centimeters. That's your that is the entire surface area. So that includes the base, that circle base, and the lateral surface. All right, there's one more object which we should discuss, and that is a sphere. Now, the surface area of a sphere, this one will be a little bit different. We're going to discuss it, but we won't discuss how to develop the formula, because the formula for the surface area of a sphere actually is kind of it's just kind of complex, and usually that formula is derived by using calculus, the methods of calculus. So that's kind of beyond the scope of our course, but we can still discuss what the formula is. So the surface area of a sphere will be equal to 4 times pi r squared, where r is the radius of the sphere. So here's how to imagine that. So imagine you have your sphere, which is like the world, the earth. You've got the center of the sphere and the distance from the center out to the surface there. That's your radius. And now imagine the equator and the circle that is made, that's a cross section of the sphere through the equator, or any one of the equators. So this is what's called a great circle. It's you can think of it as the largest circle contained inside the sphere, or it's the circle that has the same radius as the sphere itself. So, anyways, the surface area of the sphere will be exactly four times the area of the great circle. And again, I don't have a method for showing you why that formula is true without getting into some more sophisticated mathematics.